So Kazakhstan.
63.
Actually, you might find that the Kazakhstan questions seem a bit harder, at least at the beginning. So, question 1. I don't know how to spell Kazakhstan. So question 1.
The year 11 question.
So you gotta have like find all pairs of natural numbers, yeah,
Oh, yes.
such that what is it? N to the 4 divides 2m to the 5 minus 1, and m to the 4 divides 2n to the 5 plus. Was it like this?
Yeah.
Or was it the other way around?
That's correct.
Did anyone think at all about this problem? Yeah. Yeah. I mean, this is new to a lot of you, so I don't want to kind of push you too hard at the beginning. But if you, there should always be enough stuff to do that if you really wanted to spend all the time doing it, it's possible to do that. But then again, it's also like not compulsory. To like go at your own pace and do what you're comfortable with.
Which question?
There's the first question on the other worksheet. Oh, actually, that reminds me. So I think, does it have the website on that web worksheet?
No. Yeah. Oh,
yeah.
Yeah, AOPS, yeah. So that's a really good website to get like problems and stuff to try on your own, yeah. And if you're doing problems with us, so if you're doing on your own, try to do the earlier years, like 19 something, right? And then that way, when we do it together, we won't have repeated the questions. It'll make it easier to manage logistics. Okay, so if you haven't really looked at this, maybe I'll give you like 5 minutes to kind of come up with some ideas, and then we can talk about it. Yeah. I would say it includes 0 too, but some people say it doesn't. Usually they should define it, but I would just naturally say it does.
Yeah.
And then there's all these stupid arguments like, what's more natural than 0?
Is 0 natural?
Yeah.
Hmm.
Yeah, the word natural gets abused a lot.
Why do they call it
It's
natural?
arguable. It's arguable.
They should just call it either non-zero integers or not non-negative integers.
Yeah, so I guess it was counting numbers.
I know,
That
but that still causes problems. Like, do you start counting at 0?
Yeah.
I mean.
So historically, like, they didn't come up with 0 at the same time they came up with the other numbers.
What I'm saying is that they should just say like non-negative integers or just positive integers.
Yeah. So I guess there's some other notations like naturals greater than 0, natural positive. Oh, it's annoying.
Yeah, or you can just can't you just say non-negative integers? That's just easier.
Yeah.
That's divide. The line.
Divides, yeah. The line means it divides into. So the right thing is a multiple of the left thing. Yeah.
It's changing though. So how would 2n to the 5 plus 1 be a square?
can't solve this purely using algebra.
No. That's a hint, I guess.
We're
Yeah.
using complex numbers.
No.
Yeah, we're using complex numbers.
I'll use anything for complex.
Why? Complex
It doesn't have to be fancy. I mean, the reason I showed you the complex numbers is because I like you to learn something from solving the problem that you could use for another problem.
Don't tell me we're using combi on something like that. On this.
Oh no, just, like even if I did tell you that, it wouldn't prevent you from solving the problem some normal way, right?
True.
Like maths isn't magic, you know. The assumptions have to lead to the conclusions.
Yes, it
It's
is.
just sometimes the assumptions can come about in funny ways, but that gives you more ways to solve the problem, like as opposed to less, right? It doesn't have to be this weird way. It's just someone came up with this weird way, and no one else came up with anything before that, and then it became celebrated. I think there's a very normal way to do this problem that people don't actually try because I don't think they realize how to express the idea in terms of maths.
It doesn't make a whole lot of sense.
It might when you try it, you know?
Okay. That's square. That's not. I think. Would it both have to be odd? That's all I see. Yeah, odd. Well, that's quite odd. That's odd.
Okay, so did anyone... So, if you didn't see this one, I'm kind of a little bit concerned. So did you notice that like 1 works?
Yeah.
Yeah?
Yeah.
So
Yeah.
1, 1. So with problems that I don't understand, I tend to try all low numbers first, yeah? Just to get some grip on it. So if you did that, you'll know that 1 divides everything, right? So 1, 1 should work. Okay?
And both have to be odd,
Ah, both have to be odd,
which
yeah?
is quite
I
odd.
think only one.
Yes, it's quite odd.
Yes, it's quite odd.
Yes, it's odd, right? Because if this is even can't divide into an odd, right? So this even can't divide into an odd.
They both have to be odd.
They both have to be odd.
And Mr. Odd,
Do we have to prove
we can
that there's only one solution?
Oh,
Yeah.
there's only one.
From experience.
From experience, there's only one. Yeah, yeah. No, I don't like to do the experience thing because the experience is like, because maths competitions are a little bit fake. You know what I mean? They're designed to be solved. in
1,
a
3
time
also
limit.
works. 1, 3
So-
also works.
But what we really want to develop, instead of developing some kind of like weird psychological analysis of the problem, we want to develop like a read, you know? Like we can see this problem, we have a feel for how hard it is, you know?
Myself.
By the way,
Does that make
what?
sense? We have a feel for what might solve it.
1,
That's
3
what we're
also
going
works.
for. That will work for all problems. Yeah, not just
Yes.
Huh?
1, 3 also works.
The other way.
really
Yeah.
1, 3.
Yeah.
So let's have a look. Which one's 1?
Um,
M, yeah.
No, either way it works.
Oh, 1, 3, and 3 won't work.
Yeah, well, n is 1.
So 1 divides everything. So that's 2, 1, 3, right?
Yeah.
So 1 divides everything. Wait.
That's 3, 1.
1 divides everything. Yeah.
No, wait, no,
And then you 3 to the
no,
4.
m is 3. Hold on.
wait, no, that's wrong.
Oh, wait, I don't think it works anymore.
Because
Yeah,
3 to the 4 is too big, right?
Yeah.
Yeah, I just realized.
Did anyone come up with this kind of? Okay, there's 2 observations. I was wondering if anyone kind of saw. All right, one thing it might not be that big a deal, but like n and m have to be co-prime. So this is the kind of experience, like number theory experience, yeah. Co-prime, yeah.
Wait,
Can you
what?
see why n and m have to be co-prime? Like they have no common divisors, yeah.
Why?
Well, basically because if n goes into because if you have a common factor, right, it goes into n to the 4, right? So it has to go into 2m to the 5 minus 1, right? But then it would also go into 2m to the 5, right?
Yeah.
So then it has to go into minus 1,
Mhm.
right? So the common factor would have to be 1 or minus 1.
Which
Yeah.
is the only common factor.
Yeah.
So the co-prime, yeah. That helps.
Okay. So that's like a number theory observation. This is like kind of just
Normal.
getting your hands dirty observations.
And odd is just, well, duh.
Did anyone notice it's not actually that easy for like a 4? So can you see that if n divides that, like it has to be less than that, right?
Yeah.
It's not easy for this to be less than that and for this to be less than this.
Well, it can also be equal. But what if it's equal? What if one of them is equal to what happens there?
Yeah, but that's what they want.
Well,
Yeah. So I guess once I gave you this observation, I can tell you how my students finish this off from here. Okay. Actually, also Xing mainly. So can you see that n to the 4, m to the 4 divides 2m to the 5 minus 1 times 2n to the 5 plus 1?
yes.
Is that obvious?
Yes.
Yeah. So this is what I meant by something that's kind of like obvious, but you can't really put down into maths. Like, oh, the sizes don't feel quite right. Yeah.
Experience.
Yeah. But how would you express that in terms of the actual equation? So. So, but what is this product, right? It's 4 times n to the 5, m to the 5, right? Plus 2m to the 5 minus 2n to the 5 minus 1, yeah?
Yeah.
So, can you actually see that it divides, see, n to the 4, m to the 4 clearly divides this, right?
Yes.
Yeah. So actually, therefore, it has to divide that. Yeah?
Yeah.
So we have n to the 4, m to the 4 divides 2m to the 5 minus 2n to the 5 minus 1. Yeah? Okay. So if this divides that, okay, look, can you see that? That looks even weirder than before, right? This is an 8th power, basically, right? And it's dividing into like 5th powers. So that's going to break down pretty soon, right? So there's probably many ways to break it down, but let's just kind of do whatever.
I've
Yeah?
no idea, but that means that n to the 4 must divide that.
N to the 4. Ah, yes.
Which means that
Or
n
n
to
to
the...
the 4 is, yeah.
Yeah, which means that... But n to the 4 also divides 2m to the 5 minus 1. Which means that n to the 4 must divide minus 2n to the 5.
Oh, yeah, clearly, right? Because it has n to the 5.
Oh wait, no mind.
Yeah. No, but it's right. It's good that you're playing around with it.
I was trying to manipulate it, but then it just became
Yeah.
silly.
Okay, so what can we do? So here we can just write something obvious, like n to the 4, m to the 4 is less than or equal to 2m to the 5. So this is one of the reasons why you would consider this problem kind of an easy problem, because it has a lot of room to solve it, yeah? Some problems are hard because there's like only one way to solve it, and it's razor sharp, and you have to really just find that way. But this way, like this is too big. That's really what we're going for here, yeah? This is big, that's not so big, yeah? So if it divides that, okay, I'm concluding that n to the 4, m to the 4 is less than or equal to this to the 5 minus 1, yeah?
Yeah.
Is there anything wrong with what I did just then?
No.
Two cases, right? Are you just saying things that usually work?
From my experience.
Yeah, okay, there is a case, okay? Okay. Hopefully that doesn't reaffirm your values too much. Okay, so there is a weird case because, for example, can you see that if m was less than n, right? Yeah? There's no way a positive number can be less than a negative number. Does that make sense?
The absolute value.
Yeah, so it has to be the absolute value, right? Because we don't want, like, if 5 divides into 15, right?
Yes.
We can say 5 is less than 15, yeah? But if 5 also divides negative 15, right? But we can't say 5 is less than negative 15, right? So we can only take the absolute value, or equivalently, we can take two cases, right? So we can take the case where m is bigger than n, so in which case this is true, right? Yeah.
Mhm.
Or we can take n is less than m, in which case we have to reverse it. Yeah.
Yes. Okay.
Okay, so we have from here 2m to the 5, this puny fifth power, is bigger than or equal to this huge eighth power thing, plus some other stuff, yeah? And then from here, though, we already know that this 2m to the 5 is less than or equal to 4n to the 5m plus 2m, right? I just times this by 2m. 2 times 2m to both sides. Yeah? Yeah. I guess you might call this like an algebra way of solving a number theory problem. So that's bigger than that, and this is smaller than that, right? So what that means is this is bigger than this, which is bigger than that. So this is bigger than that, right? So 4n 5m plus 2m is bigger than or equal to n to the 4 m to the 4 plus 2n to the 5 plus 1. Yeah?
Hold on.
Yeah. Actually, when I heard about, so the HSC marking technically was like any valid method works, should get full marks. Except that there's a big technicality involved where like it takes ages for the markers to figure out how like that you're right in the first place. Like okay, does this make sense?
Yes.
Got to here, right? Because this is bigger than that, which is bigger than that. So this is bigger than that. And that's what I wrote. Okay. Now this might look complicated, right? But it doesn't have to be. Like we have so much room to work with. We can even delete like these terms. Yeah. Because the main problem is the eighth power, right? Like if it's bigger than the eighth power plus all that, it's just bigger than the eighth power by itself, right? Yeah. Okay. So for example, you can divide by m now. Yeah. You have 4 n to the 5 plus 2 is greater than or equal to n to the 4 m cubed. Yeah.
Yes, that does not look right.
Yeah, it's getting worse and worse, right? Yeah. You can make it even more obvious by dividing by 4n to the 4 by n to the 4, yeah? And get some tiny, so it's basically some number that's roughly 4n plus 1 is bigger than or equal to m cubed. Yeah? It's becoming obviously false, right? So how can 4, so the number n is actually smaller than m, right? And yet 4 times n plus 1 is bigger than m cubed.
Wait. Yeah, m is larger than n. That's
Yeah.
the main thing.
So this already fails for when n is like bigger than 4, right?
Which means that n is less than or equal.
Yeah. So
Which means that we
we
can
could
just
say,
try
like,
1, 2, 3, and 4.
so if we assume m is like, so m cubed is greater than n cubed, right?
Yes.
Which, if n is greater than 4, actually let's say n is greater than 2. This is greater than or equal to 4n, right? If it's strictly greater than 2, then it's strictly greater than 4n, right? It's strictly greater than 4n, it's greater than or equal to 4n plus some small number, right?
No, but it has to be an integer.
Exactly, right? So it has to be bigger than or equal to 4n plus 1, which is bigger than this, right? So if n is bigger than 2, this is a contradiction.
Yes, the
Yeah.
n is either
n
0
has to be 1.
And it has to be.
Yeah.
N has to be 1. Which means that 1's the only solution.
Yeah, so notice that we can't get away from this because 1 is a solution, right? We can't just conclude it doesn't work. Or actually, we can because that solution has m equal to n, right? But would you be able to do the other direction yourself? Yeah. What happens if m is less than n? Yeah, so and then what happens if m is equal to n? No, why? Experience. Reincarnated beings.
That's just it's quickly
Pretty
coming
obvious.
me.
So can anyone come up with a quick reason why if m equals to n, it has to be 1, 1?
Because 1 works, and the other one can't work. Mm-hmm.
I mean, this basically, I mean, if you try it, it'll be obvious, right? But we have already actually tried it, so we know that they have to be co-prime, right? So the only two numbers which are equal in co-prime are like plus or minus 1 and plus or minus 1, yeah?
Yes, and natural numbers can't be negative.
Yeah.
So, yes.
Okay, so then all we have to consider is that m is less than n, right? Maybe that could be like a test or something. See if you understood that. Alright, how about this? I'll give you like 5 minutes to collect your thoughts. And then you can guide me through what to do for when m is less than n. Okay?
Just wondering, is this stuff mine?
Yeah.
Oh, okay.
Delivery from someone, I don't know.
I was like, wait, who put this on my desk?
Yeah.
It just seems weird that Paul's dropping stuff on my desk. Wait, I just quickly figured out how I'm gonna do this permutation thing.
Oh, very nice.
But basically what I can do is I can just say that I can just pick
Keep your voice down a little bit.
I can just pick a point on this line.
Yeah.
I can rotate it by I, and then I just have to prove that it's on the line, on that line.
Okay.
Or I can just pick the origin and then prove that if I rotate it, it becomes on.
Mm.
Wait. Yeah. Hold on. You can't really rotate the origin. How do you I want to say if I rotate it that way. Yeah, but how do you rotate something about another point? I know how to rotate it about the origin.
Oh,
How do you rotate it about another point? Like, I want to rotate it around P.
well, like you do like something minus p and times something minus p. So like if you minus p, it's effectively putting p as the origin. If you minus p from everything, you basically move the origin to p.
I see about that. I'm just trying to figure a way to prove the perpendicular, because if you prove the perpendicular, you prove it's the tangent.
Yeah. Actually, this might be a good time for a break as well. So basically, in the next 15 minutes, you can do whatever you want, including this. And yeah, you can go to the bathroom.
Wait, why did you use the coordinate geometry approach and use the formula for the circle and the formula for the line?
Oh, you can as well, yeah.
Yeah.
It's just, I think people might already know those approaches. Sure. Oh yeah, you can actually, as long as you don't make like a noise during class, you can even eat during class. Don't chew loudly or stuff. Spit it on people.
Wait, is the formula for a circle in the coordinate plane real squared plus imaginary squared equals 1? Because of Pythagorean theorem?
Yeah. That's like almost just it's still just the Cartesian equation.
True. It doesn't. I'm trying to find a way that does not use the Cartesian.
So a circle is more like the vector one is more like this, right? Like if the center is 1, and the radius is r, then all the points which are distance r from 1 is a circle. Yeah? So that's like a more complex number equation of a circle.
So, wait, how does that work? Z minus 1.
So if you have z, then you have 1, right? Z minus 1 is the vector that goes to that, right?
Wait, let's go to this here.
the length of that vector, if it's always fixed at r, right, it means the radius is r.
Yeah, but my circle is the origin.
Oh, then in your case, z equals 1. That's the equation of the circle, right? It's all the points with length 1.
Okay, so
Wow.
I just have to prove that that circle is
I mean, everything like upgrading the walls, like
one.
Yeah.
And the equation of the line, I just have to prove that there's only one intersection. There's only one solution.
I don't even.
Yeah.
Yeah, so I just find the equation of the line. Of the line PM. So the line PM. What's the line PM? The line PM. Well, it's A times. It's A plus lambda B minus A. A. What's A? Well, A is P. So I can do P plus lambda M minus P. Okay.
What?
Share with the class.
Oh. Oh, cool. Why don't you do it? You can share with the class.
Okay.
Guys, Ryan has a gift for you guys.
Thanks, Ryan.
I guess on behalf of EduVision.
Thanks.
Wait, is this supposed to be